Hi everyone, I'm Christine, and hopefully after watching today's video, you will understand the basics of Punnett squares. Punnett squares are used to determine the potential genotype of offspring between a two-parent cross. Before we begin, there's some vocabulary that you will need to learn. Alleles are a form of information stored on the chromosome. Today I'm going to talk about two, both dominant and recessive. Dominant alleles show up in the phenotype and mask the presence of recessive alleles. Recessive alleles show up in the phenotype only in the absence of dominant alleles. Homozygous and heterozygous organisms are similar but different. Homozygous organisms have two identical alleles, which can be both dominant or recessive. Heterozygous organisms have two different alleles, which are typically dominant and recessive. The phenotype of an organism are its observable characteristics, such as blue eyes and brown hair. The genotype of an organism is its genetic makeup. Today's example is going to use frogs. We're going to use green frogs and blue frogs. Now, the green frog that has the dominant homozygous genotype is listed capital G, capital G. The green frog that has a heterozygous genotype is capital G, lowercase g. And the blue frog has a recessive homozygous genotype, lowercase g and lowercase g. Now, in this example, I've used a heterozygous parent cross in order to get all types of offspring. By listing the parents in such a way, you bring down the letters and fill them in accordingly. Now, all the frogs that have a capital G in their genotype will exhibit green. The frog that will exhibit blue has two lowercase g's, which are both recessive alleles for the blue genotype. Today's example has hopefully helped you learn the basics of Punnett squares. In summary, this example showcases the different genotypes heterozygous parents can create.